Hey class, so we're going to shift gears a little bit away from the core of the 3D engine and talk a bit more about visibility. Now, it turns out that when you make a 3D scene, you don't typically just have a couple of objects like we've had in our toy examples. You have these scenes really full, chock full of objects, lots and lots, thousands, hundreds of thousands, maybe even millions of polygons and triangles, and it's really full. And then in this scene somewhere we have our 3D camera, right? And it has this view volume where it's looking into our scene. And it turns out that at any given time, this is my near and my far planes, okay? It turns out that at any given time, we can't see most of the geometry, right? So a lot of the geometry in this picture is behind the camera. We might have some stuff in front of the camera, of course. We hope so, because we're looking at these things. Let me just draw some more geometry here. Let's see if I get this right. There we go. Okay, but at any given time, you see the amount of geometry that we can see is only in our view volume here. Everything else is not seen, okay? So most geometry in a complex world by far, we're not talking like 5%, we mean most, like 95%, is not visible. Most of the time. It turns out that's the opposite. We're only looking at a small subsection of the geometry at any given time. And so the single biggest thing or best thing you can do to speed up your graphics is this problem here. So the single biggest impact on speed of 3D rendering is visibility determination. Okay, so if we can cut out these things before rendering them, before going through the transforms, we save a lot of work. I'm going to highlight a few cases here. Okay, so all the stuff behind is just simply not in the camera view, right? We shouldn't be transforming these and considering these and rasterizing. None of this should happen. We have some things that are partially in view. Okay, so it's on the edge of the view frustum. So we can see it, but it's not really in view. We have things that you think might be in view, but they actually aren't. These are too close or too far, because we have the near plane and the far plane. If they're too close, too far, we can't see them. Even things that are really close. And you can imagine in a real camera, sometimes you have things really close, but it's so out of focus you can't see it, like a speck of dust on your lens. You might not see it, right? Okay. We also have, yeah, I'm gonna draw a few more things in here, right? I did that wrong. That's okay. I can fix it. So this guy is in view, but occluded. There's something in front of it. Occluded. You can't see it. And we have another triangle here. Maybe this is in view, but maybe it's facing away. And we've already learned about back facing. And we'll come back to that in a couple of slides, a couple videos actually. But it's facing away. So we have all these reasons why things aren't being drawn to the screen. So I got all of my examples, right? Yeah. So the 3D pipeline is actually very expensive. It's very slow. It's expensive. So the earlier we can exclude from the pipeline, the better. So for example, up here, you can imagine maybe, hey, look, Jim, this is the camera axis. I know all of that stuff's behind the camera. If you knew that ahead of time, you wouldn't even touch it. Just exclude anything behind the camera. Okay. So we're going to learn some techniques for doing this kind of optimization. Other things like the ones that are maybe too close or too far, it might be a little more difficult early on to determine whether they're in view or not, and we might need to wait until further stages in the graphics pipeline to make that decision. So I'm going to introduce some vocabulary. One is culling, and culling is simply removing an object from the pipeline at any stage. Okay, that's culling. And the other word I want to introduce is called clipping. And clipping is when we draw only a part of an object. So because it's only partially visible. That's an S. Now there's a couple of caveats here, unfortunately. I'll just give examples. Up here, culling might be, hey, look, we're going to cull these faces, these shapes, because they're just not visible. We know that right away. So get rid of them really early in the pipeline. Later, you might cull the shapes that are outside there. It might be later in the pipeline, but you still figure out later once you build your frustum and go, oh, I can't see it, we can cull it. But these ones here that are like overlapping and they're going to be drawn inside, but partially outside, those are clipped. Okay? But let's talk about that caveat. Unfortunately, these terms live in the real world, so there is an inconsistent use of words. Inconsistent use of these terms, okay? So if you look on the internet, even in textbooks, people use them interchangeably sometimes, but they are different. But that's a battle I might not win because there's just so much literature out there where people just mix and match willy-nilly. And part of the problem is sometimes like they do overlap. So you can have a clipping algorithm, for example, right? You might start to look at something that has an overlap in here, and through your process you might go, actually, I can't see any of it. So clipping algorithms can lead to culling. Okay, so you can cull a shape instead of clipping it. But I'm not too worried about the breakdown, but you should know there's two different things that's happening. We're excluding it from the pipeline, and we're only drawing part of it. But those terms are used inconsistently in the industry, unfortunately. So there are many, 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 many approaches to this, okay? This is all algorithms. And the way we'll introduce it in this class is I'm going to start from some of the ones that are more necessary and then more easy, and then talk about some of the bigger picture ones. So one of the issues that I'll get right into after this video is depth sorting and depth testing. Basically, occlusions. If something's in front of something, something's behind something, we want to maintain correct visibility. Okay. Excuse me. We can also test our geometry being like a triangle or a model or a car, against the view volume. So we can make the planes. We can figure out the planes of our view volume and test those against geometry to cull or clip. So our frustum or our view volume, depending on our projection, it gives us a shape in 3D space. We can use that shape and test what's inside of it and what's outside of it. And then there's a bigger approach, which is scene level or world level sorting, basically. These data structures. And they let you query, like I'm looking in this direction, what's in front of me, and these enable you to filter out whole regions. Okay, so if I come back here, then this thing on the left here, I wish I could have a pointer in here. This thing on the left here, you'd want to get rid of that with some big world level data structure. But when something's kind of in front of your camera and it's harder to tell, then you do the view frustum or your view volume testing, right? And then once you know what you're going to draw, then we have to take care of visibility of the things I'm going to draw, the order and what's occluded. So we're going to go through all of these things in this unit. All right, so we'll come back in the next video to talk about talk about depth sorting and things like that.